Mastering simulation modeling. Simulation modeling without strategic approach is just pretending to be proactive. How can an organization utilizing simulation modeling for operational excellence identify and differentiate between the various types of simulation modeling approaches, including but not limited to discrete event, system dynamics, and agent-based modeling, to ensure the most effective and efficient operational strategy? Identifying and differentiating between various types of simulation modeling approaches is crucial for an organization to ensure the most effective and efficient operational strategy. To achieve operational excellence, it is essential to understand the strengths and weaknesses of each approach and select the most suitable one for a specific problem or system. Discrete event simulation (DES) modeling. Discrete event simulation models are used to analyze systems where events occur at specific points in time. This approach is ideal for modeling systems with discrete entities, such as customers, products, or machines. DES models are particularly useful for evaluating the performance of systems with queuing networks, inventory management, and supply chain management. Key characteristics of DES modeling. Discrete time models, where events occur at specific points in time. Entities move through the system in a sequential manner. Suitable for modeling systems with static or dynamic resources. Often used for evaluating performance metrics, such as throughput, lead time, and utilization. System dynamics, SD, modeling. System dynamics models focus on understanding the underlying dynamics of complex systems, considering the interactions between different components and their feedback loops. This approach is useful for modeling systems with feedback loops, nonlinear relationships, and delays. SD models are particularly useful for evaluating policy decisions, strategic planning, and organizational learning. Key characteristics of SD modeling. Continuous time models, where changes occur over time. Focus on understanding the dynamic behavior of systems. Suitable for modeling systems with feedback loops, nonlinear relationships, and delays. Often used for evaluating policy decisions, strategic planning, and organizational learning. Agent-based modeling, ABM. Agent-based models simulate the behavior of autonomous entities, such as individuals, teams, or organizations, interacting with their environment and each other. This approach is ideal for modeling complex systems with autonomous decision-makers, social networks, or decentralized systems. ABM models are particularly useful for evaluating the emergence of patterns, self-organization, and adaptation in complex systems. Key characteristics of ABM. Models autonomous entities, such as agents, interacting with their environment. Focus on understanding the emergent behavior of complex systems. Suitable for modeling systems with autonomous decision-makers, social networks, or decentralized systems. Often used for evaluating the emergence of patterns, self-organization, and adaptation in complex systems. Hybrid modeling approaches. In many cases, a single simulation modeling approach may not be sufficient to capture the complexity of a system. Hybrid modeling approaches combine different simulation modeling techniques to leverage their strengths and overcome their limitations. Hybrid models can integrate DES, SD, and ABM approaches to create a more comprehensive and realistic representation of complex systems. Key characteristics of hybrid modeling approaches. Combine multiple simulation modeling approaches to capture the complexity of a system. Leverage the strengths of different approaches to overcome their limitations. Suitable for modeling complex systems that require a comprehensive and realistic representation. Often used for evaluating the performance of complex systems, identifying optimization opportunities, and predicting the impact of changes. Selecting the most suitable simulation modeling approach. To ensure the most effective and efficient operational strategy, organizations should consider the following steps when selecting a simulation modeling approach. 1. Define the problem or system to be modeled, and identify the objectives of the simulation study. 2. Determine the level of complexity and the type of dynamics involved in the system, discrete, continuous, or hybrid. 3. Evaluate the strengths and weaknesses of each simulation modeling approach, considering factors such as the level of detail required, the nature of the system, and the availability of data. 4. Consider the scalability and flexibility of the simulation model, as well as the need for real-time or fast-time simulation. 5. Select the simulation modeling approach that best aligns with the objectives of the study, the characteristics of the system, and the available resources. By following these steps, organizations can ensure that they select the most suitable simulation modeling approach for their specific needs, leading to more effective and efficient operational strategies.